Hi, I'm Sam, and Jay and I are going to be talking about Angler, an interactive visualization tool that we built to help machine translation practitioners prioritize model improvements. Machine learning models can fail in unexpected ways, but not all failures are equal. Consider this example from a machine translation system. Some machine translation errors are easy to spot. Even if I can't speak Spanish, I can probably tell that something has gone wrong in this example on the left, just by comparing the numbers. But other kinds of errors can be really tricky if you don't speak both the source and the target language. Imagine I was trying to tell someone that they might feel burnt out from their fever, and instead they thought I was trying to tell them their fever might be deadly. We can see from this example that machine learning model failures can vary a lot in terms of how easily users can catch them and how severe the consequences are if they're not caught. Driven by this insight, we wanted to explore how we could help practitioners detect and prioritize failures that are most detrimental to users. This is especially important in the machine translation context because gathering ground truth data from professional translators is really expensive. So we want to be able to prioritize those resources on issues that matter to end users. We started out by understanding how people approach this problem in other areas of machine learning through a formative interview study with 13 practitioners at Apple. Our conversations focused on how these practitioners source and prioritize potential issues with their models. Some of the strategies we identified included user testing and user-reported errors, brainstorming with domain experts who know a lot about how people use or are impacted by the model, and identifying usage patterns with low training data coverage. This third strategy is the one that we decided to explore further with Angler. Specifically, we built Angler to support practitioners in building challenge sets, or small targeted test sets that they can use to validate, evaluate, and ultimately prioritize potential issues. Next, I'll talk about how we developed two types of challenge sets for machine translation and how Angler fits into this evaluation workflow. Then I'll turn over to Jay for a system demo. The first step is to surface challenge sets, which are small subsets of data that target a potential modeling issue. In the machine translation context, it's really hard to automatically detect translation errors, especially when there's not already gold standard reference translations. So we have to develop methods that surface potential issues and then enable practitioners to explore those issues further to prioritize which they will invest in fixing. We took two approaches at this point. The first was to apply unit tests that check for simple behaviors. For example, if the source sentence contains an emoji, the translation should contain the same emoji. The second approach was inspired by our interviews. We compared usage logs, or what people want to use these models for, against the model's training data to identify areas of low coverage. We then used a topic model on these areas. Of low coverage to build meaningful challenge sets that practitioners could explore. With challenge sets in hand, practitioners can now use Angler to explore each set in more detail and decide which ones they want to prioritize, for example, by collecting new relevant training data. I'll now turn over to Jay to show us in more detail what practitioners can do with Angler.
Now we'll give a demo for Angular. So Angular is a web-based interactive visualization system user can open in their browser. When user opens the tool, they will see a table view where each row represents a trend set. User can scroll to see different trend sets. User can hover over different columns to see the attributes. For example, log count, similarity score, train count, triumph score, and train ratios. User can also click the column to sort all the rows based on that attributes. For example, here I'm sorting based on the familiarity score or the train count. User can click a row to see the preview of the trend set. On the right-hand side, we have some representative keywords. On the left-hand side, we have some 100 random sampled sentences from the trend set. User can click a sentence to see translation from English to Mandarin Chinese. Same thing for these trend sets. User can also use the search bar to search the trend sets by the keywords. For example, here the name will have a headache, so this one will give a very interesting trend set. So finding interesting trend set, user can click the show details to enter the detail view. In the detail view, we'll show more perspective about the particular trend sets. For example, in the keyword view, so we have the most representative keywords. User can click those keywords to filter the sentences by sentences having those keywords. User can again scroll through the sentences to the sentence, also click sentence to see translation from English to simplify Chinese. User can also change the different focus view by clicking the thumbnail to send the spotlight view. For example, here, so we have the sentence embedding view. So we run a sentence transformer to get some latent embedding of different sentences, and we use a UMap to project them into those 2D plots. And the contour plots means like the KDE distribution of overall training data set. So user can pan and zoom to see the sentence embeddings. User can also hover over a dot to see the translation and also the original sentence. So we can see there is some interesting clusters of different sentences from this challenge set. User can also click the settings button to toggle to turn on the different contour plots. So here the green means the usage log density, and the green means the training density. So we can see there's a mismatch between two densities. User can pan and zoom to see the usage timeline, and also use like brush to filter different timeline to select a range. And all the other views will be updated to only show sentences in that range. User can again to search the sentences on top of that filter. The next spotlight view is chart score. So here we have a bar chart. User can brush to see the different sentences within that chart score. Similar to the formatted score, user can brush to filter the formatted scores. And for the input source, user can click to select different sentences from the particular source. And finally, we have a unit test spotlight. User can click to see the sentences from other unit tests challenge sets. User can also click the edit button to edit different sentences, so they can remove sentences from the challenge sets. User can also click export button to export all the sentences from the challenge set. Then they can return this challenge set to the other annotators to annotate this challenge set.
Thanks, Jay. We started this work interested in how we can help practitioners detect and prioritize failures that are most detrimental to users. To see how Angular meets this goal, we conducted a user study with 7 machine translation practitioners across engineering, product, and UX roles. Perhaps intuitively, their first priority was prediction quality. They wanted to find the poorest quality translations. However, in the machine translation context, this is really hard, especially in usage logs, where we don't have any reference translations to compare to. Given this uncertainty, practitioners turned to other criteria. For example, they wanted to prioritize improving the model on critical use cases, rather than things like spam and automated messages. They also wanted to prioritize issues that could have the most severe impact on users. One product manager said that Angular gave them a nice way to distinguish serious problems from surface-level formatting issues. And lastly, participants wanted to prioritize translation annotation resources on issues that were actually complex enough to need translators' help, rather than simpler things that could be solved with strategies like data augmentation. We also saw that using Angular helped practitioners better understand their model's behavior, as well as what their users wanted to use the model for. And they saw Angular as a great way to enhance communication and collaboration across different parts of their team.
Reflecting our development and evaluation of Angular, we want to discuss our findings in a broader context. First, we want to talk about the trade-off between human and automations. So some might argue that it's very time-consuming and tedious to go through all the challenge sets using Angulars, so why not just send all the challenge sets to the annotators? So with our novel methods like unit tests and topic modeling, we can automatically surface a lot of interesting challenge sets. However, there are too many of them, so it's very expensive and costly to send all the challenge sets to annotators. So for future researchers, definitely it would be valuable to design more better methods to more precisely surface interesting challenge sets. And also our method as a whole pipeline can be easily generalized to different model types. For example, think about computer vision, like such as image classification. For our unit test method, we can think about perturbation methods. For example, we can rotate, resize, or maybe changing the lighting situation of some images, and then we measure how sensitive the model prediction is to those perturbations. Then we can define some threshold to surface some interesting challenge sets, and we treat them as a unit test. And for the topic modeling, researchers can also compute the embeddings for the images and do some embedding clustering to surface some topics of different images. And similar to our pipeline, user can surface some unfamiliar images and put them together into a challenge set. And in the findings, we found that unit test is a very, very interesting research topic. During our evaluation, all the participants extremely appreciate unit tests. They think unit tests is a very easy and intuitive way to find glaring translation mistakes, and it's very easy to adopt into their existing workflow. So we think there are the rich research opportunities in the future to study unit tests. For example, researchers can study unit tests for data validation, unit tests for machine learning operations. And a user can also use our Angular as an inspiration to design interactive tools to help machine learning practitioners to write, organize, and maintain unit tests for machine learning systems. And that's all about our presentation. Thank you so much for your attention.